So thank you very much to John Dirkman of Schneider-Electric as we talk today about best practices for IT and OT convergence. And I've got a question here. You mentioned communications in passing, and the question is, do you have an opinion on the best approach to merging IT and OT communications, and which organization should that communications reside in?
Oh, that's a great question. Yeah, there's certainly no one way or maybe even best way to do that. Often people divide this into real-time and enterprise. And sometimes if they implement enterprise service buses, for example, they have different enterprise service buses to handle those different requirements for latency and for communications. I wouldn't necessarily say there's one best way. Oftentimes I see the knowledge of communications as part of the IT group. But oftentimes there's people in the OT group as well who have input into that. So again, it's taking the right people with the right knowledge from your organization and bringing them together.
Thank you. And William asks, what about IT personnel understanding and being trained on OT issues and concepts? And he says that's often a bigger gap than the other way around. Any thoughts?
Yes, I agree with that. Definitely, William. That's a great insight into that. The training process is definitely very important. You know, oftentimes IT people come in with a computer science background, whereas your OT people might come in with electrical engineering background. And those two are different. There's some overlap, but those two are pretty separate worlds.
Yeah.
So I think that's a great idea to do some upfront training, even reading of literature. And also, I would say, I have seen a lot of benefit from even co-locating these groups for some period of time. So you can kind of hear the background discussion of the IT guys and the OT guys if they're really that separate in the organization. And oftentimes I've seen it that way. That collaboration, again, between the groups is vitally important in this. I've seen some team building exercises where each group gets kind of better insight into what the other teams do. That's been valuable as well. That's a great question, William.
And Pratik wants to know if you think data analytics is going to play a role in this IT-OT convergence.
Oh, yes, absolutely. Absolutely. This is really what this is all about. This is taking all of this data from all of these devices and making sense of it, and using that data to operate your utility as efficiently, as safely, as reliably as you can. So that is, I think, is really at the heart of it. Whether you use, which functionality you use to address that data, use it for demand response, for volt-var control, for fault location. That's really what it's all about. I would say, yeah, definitely drilling into that, understanding what does that mean? What data do you need? And how often do you need that data? And what are you going to use that data for is very, very important.
Thanks. It's my great pleasure as we talk today about best practices for IT-OT convergence to bring up someone who's been right in the heart of this in his own utility. Fred Fletcher is the Assistant General Manager at Burbank Water and Power. He operates plans and develops the power supply. He's got decades of experience in all things grid, and we're very lucky to have him along today. Fred, welcome and take it away.
Okay, thank you. Back in 2005, Burbank was just completing the modernization of our local generation. That modernization was a major project. It took several $100 million, and it took a construction period of about 3 years. During that same time, we put in a new modern customer information system billing system, as well as a modern SCADA system that used fiber and Ethernet for high-speed access to the data in the substations. At the conclusion of those projects of modernizing the power plants, I got the assignment to take on the challenge of modernization of our whole system for increased renewables. That was in 2006. The planning and engineering associated with this modernization has been a lot of work. Like I said, we've been working on it since 2006. I've been an AGM level manager since 1980, and I'm used to being the younger person in my division. In fact, in 2006, I was the youngest manager and about at the average age of the people in the division. However, we've gotten through this problem of how we're going to move to the next generation, because now I'm about the oldest, and we've made a lot of transformation from the baby boomers to the next generations. So I think any discussions you've heard about how making those changes, those are changes that are occurring now throughout the industry. Burbank is very much like a lot of other utilities in this country. We're a good representative utility. We're vertically integrated. We have our own fleet of generators, transmission. We operate our system in Los Angeles with LADWP. We also are required by LA to keep our loads and resources in balance, at least on a minute-by-minute basis. We operate a power plant for not just Burbank, but also 6 municipal utilities here in Southern California. We operate a hydroelectric plant up in Washington for 2 municipal utilities. And our makeup is we've got coal for about 40%, large hydro, which is a Hoover Dam, for about 5%. We have nuclear down at the Palo Verde Nuclear Generating Station, and the rest is gas. But our newest resources that we put on, we're 25% renewable, and we've even got a nice mix there. We've got wind, biogas, solar, geothermal, and small hydro all there. We have a trading floor as well, so we trade power and natural gas throughout the West using our extensive transmission system, as well as some of our natural gas reserves that we hold. When we started doing this work, we saw the need to put together this modernized system that would heavily optimize power supply. 2/3 of our costs are in transmission and generation. Being able to make savings there is key to be able to make a savings to fund and produce the money needed to make these innovations work. We have been able to make these innovations with virtually no impact on our rates by watching our costs and making sure that we found ways to get efficiencies here. Of course, we did receive a $20 million Smart Grid grant. That helped a lot. But we want to keep a strong emphasis on affordability, reliability, and sustainability. Those are key things in making these things work. The current challenges we face are pretty important because, Burbank is facing a lot of things here because we're in the heart of the regulation here in California, but we're not part of the California ISO. So we're going to respond to this much like other utilities in the country are. That means that we're taking a look at these integration of these variable generation resources, wind and solar. In 2 years from now, in 2016, Burbank, we expect to have 50 megawatts of solar energy in place. On a light load day, at solar noon, we expect to have a load on the order of 135, 140 megawatts and 50 megawatts of solar. So we'll be over 1/3 of our resources will be supplied by solar. That'll mean our thermal resources will have to turn on further than their minimums, and so we'll be in excess generation. So we have to be able to handle that because that's just 2016. We're still going to see more solar beyond that. So we have to have ways to be able to integrate and handle that. That's part of what this new tools will help us do. We face greenhouse gas reductions. Our coal plant is 40% of our energy portfolio. We're going to have to move from coal. That's going to create a big gap in my energy portfolio. But it's something we've got to take care of. But if I just fill that with natural gas, I'm going to have too strong of a dependency on natural gas. So that means that we've got to find a way to take renewables even further than we have now, because the only alternative to natural gas that I know of is renewables. Now, putting those renewables in typically requires more transmission. But more transmission costs a lot of money. Before I go out and commit to new transmission, I want to find out what can I do to better manage our resources, apply storage, demand response, targeted energy efficiency, and other methods so that I can reduce my peak load and consolidate my resources remotely with storage so that I can maximize the use of my existing transmission. I want to defer capital additions. In these new changing eras we got, it's so important to manage costs. We've got to find ways to keep our costs down and avoid capital programs if we can. And here's another one that's important. Power restoration. We're having, with our new tools that we're using, we need high reliability on the power grid. And we face even threats of people trying to take down the grids. We need to be able to restore power quickly following a regional outage, especially an earthquake. We can expect those. And we need to be able to recognize that with synchrophasers, respond, safely put our plants into suspension, isolate the system, and restart, and hopefully do that within an hour. That's what I'm trying to do. These are the business challenges. We're seeing the business model of the electric utility industry is changing. This is not the first time it's done that. We've seen these changes a number of times before, and we have responded. I talked to some of the people in my early days who were involved with some of the changes when the Federal Power Act was passed in the 30s, and it was considered to be a change in everything. We got through it. We went through the high growth periods of the 1950s and 60s. We went through the oil crisis. We went through deregulation, a number of things. We can respond. We've got intelligent people here, but we have to know what these things are. We're seeing customers put their own solar and combined heat and power in. You know, we've got Walmart, we've got IKEA, even Disney are looking at putting these tools in, and those take away points of how we're going to pay for our system. We've got to be able to respond with our rates. Demand response for new services, being able to put demand response is not as easy as it sounds. Putting demand response in is thought with problems, and we've been working with Schneider recently on tying this in, so we've got a complete way to handle this. Fortunately, the new tool we've put in place has the intelligence to manage that. Helping us pay for this again is the emerging energy imbalance and transactive energy markets. These look like tools that we can use so that we can find ways to use these resources on an inter-utility basis. Moving to inter-hour scheduling. This new tool that we've got is designed to work on a 5-minute basis. As short as every 5 minutes, we can re-optimize the system. With this increased complexity that you have with the 5-minute type level of scheduling, it's going to be more difficult to settle at the end of the month. So we need settlement tools so that we can have our dispatchers do this. Now, the power system operators, because of all this stuff, are getting a lot more stuff put on there. One of the things we're doing is to reevaluate the span of control that the power system operators have had to do. One of the things that we did in the utility here to help get the money to pay for all of our changes has been a stronger emphasis on safety. By reducing our accidents, we've been able to reduce our workers' comp, and we've been able to move that from a 16% burden on our wages to less than 4%. So being able to reduce accidents is an important way to get money to help pay for increased automation, and also helps pay for the training and change management needs to be done. Now what this does do, though, is this moves a much higher operational role for SCADA than we're used to. We're used to 24/7, but this is like 24/7 on steroids. It has to be responsive. It can't. If it does fail, we lose a lot. So let me show you what the overall Smart Grid program that we put together was. Let's go to the next slide. Okay, this is the program that we developed from 2006 to 2009. And this is what we put into the DOE. Now, the core thing that we've got here is our Cisco-powered fiber optic network. That's 10 gigabits fiber optic switches that are carrier class that we can tie in through transit-type level service into the internet at 2 locations, both here in the San Fernando Valley as well as downtown Los Angeles at Tier 1 internet providers. We also have a Tropos citywide wireless mesh network that covers it. And within inside each of our Tropos wireless transceivers, we have a trillion GE AMI collectors, then tied to all the meters that are about the city, where we have every customer on electric meter. Then we use eMeter to do our meter data management system, and we use Oracle for our new CIS-BS system. Okay, we got our command and control stuff that you're doing. We upgraded the SCADA system, and we've put in this integrated automatic dispatch system that is a joint system by Open Access Technology International and Telvent/Schneider. Plus, we're designing a new power operations center so that we can better tie our energy control center and our power production people in a common center so that we can more tightly tie operations both at the power side and at the distribution side. Security has always been a strong feature. We've worked with our consultants to help us. We've used a lot of the Department of Defense's approaches for physical security because we started this work before NERC had got things defined, but our stuff clearly complies with the NERC approach. A lot of the NERC stuff is based on the Department of Defense stuff. The distribution side, you might notice that what's not there is we do not have a DMS in there yet. We have not got the solution for the DMS because that has to work tighter with the demand response, and as the demand response element isn't quite solved yet, the DMS we haven't got in place yet. But I see it coming into place. The key thing that we've used to tie this together has been the GIS. The GIS has been the important thing to tie the operational utility type things in with the enterprise. A lot of our interfaces go through that geographic information system to tie the enterprise in with the OT stuff. The project that I'm most excited about is energy storage and Black Start, and those ones I think are going to be exciting things that we're going to be developing next.